This is Algebra Lesson 11-1, Part 1, Simplifying Radicals. A radical expression is an expression that contains a radical, such as 2 square roots of 3 or the square root of x plus 5. To simplify radical expressions, you remove perfect square factors from the radicand. That would be the thing underneath the radical sign. Remember that the radicand is the quantity or expression under the radical sign. There, look, I'm repeating myself. The multiplication property of square roots simply says this. If I have a number and the number is greater than 0, and I can make the square root of AB is the same thing as taking the square root of A times the square root of B, which essentially means this. I can have the square root of 2 times the square root of 3, and that's the same thing as saying the square root of 6. Those are synonymous. They read the same frontwards and backwards. So, you can use this property to simplify radical expressions by rewriting the radicand as a product of the perfect square factors times its remaining factors. Okay? There are two ways to do this. Pretty much, I use only one way pretty much because of the fact that it's a lot easier for you. I will teach both ways, and if you're good at figuring it out, that's great. If you're not, that could be a problem. So method 1 says that you should find as many perfect square factors as you can. Okay, so if I look at the square root of 192, if I put that in my calculator, I would get a decimal answer. If you have one of those calculators that breaks it down in radical form, and I know which calculators those are, you will not be allowed to use that calculator on this chapter. And you will have to find some other different type of scientific calculator that does not break it down to perfect squares. I know which of the 6 different brands of calculators work this way, so be sure that you follow the directions. So here, I know that this happens to be the square root of 64 times the square root of 3. I just happen to know that. You may not know that. And if you don't know that, you might want to actually do method 2. The square root of 64 is 8 times 8. So the square root of 64 is 8. So this would be reduced as 8 square roots of 3. Now let's say you didn't know this was the perfect square. This was square root of 192 was the square root of 64 times the square root of 3. The second way you can do this is break it down into factors. For example, I know that 192 is 2 times 96. Okay? 2 is a prime number. What we want to do is we want to break things down to prime numbers. So if I took 192 and divided it by 2, I get 2 times 96. 2 is prime, but I'm going to leave it there. 96 is not. 96 breaks down to 2 times 48, which breaks down to 2 times 24, which breaks down to 2 times 12, which breaks down to 2 times 6, which breaks down to 2 times 3. Now I have everything down to prime numbers. Now what I do is I pair things up. Since, if you notice over here, a perfect square has to have 2 numbers, right? 8 times 8 multiplied together equals 64. A perfect square is a number that is identical multiplied by another identical number that's identical. 2 numbers that multiply together to get me my number. So 8 times 8 equals 64. So that's why the square root of 64 is 8. So here we're going to look at this. We talked about square roots a little bit before because we talked about perfect squares before when we worked with perfect squares earlier this year. I want to pair up numbers because it's kind of like this. They go in pairs. Just like you go to the store and you buy a pair of shoes, you hope there are 2 shoes in the box. There's only 1 pair of shoes that you purchase, but it has 2 shoes. Just like socks. I buy a pair of socks, I better have 2 socks in the package. It's still only 1 pair. So I'm going to circle my 2's here. There's a pair, there's a pair, there's a pair. And 3 here doesn't pair up with anything. Whatever pairs up goes outside of the radical, but you only take 1 thing. Remember, this is 1 pair, this is 1 pair, this is 1 pair. So it would be 2 times 2 times 2. Square roots of whatever was left over goes back underneath. So 2 times 2 times 2 is 8, so this becomes 8 square roots of 3. Exactly the same answer as we got when we used the other form. It may take you a little longer for method 2, but if you can't find perfect squares, it's actually faster. So let's take a look at some problems. You can also simplify radical expression that contains variables. A variable with a non-zero even exponent is a perfect square. So any variable to the second power, fourth power, sixth power, eighth power, 10th power, 12th power, etc. is a perfect square. Variables with odd exponents other than 1 and negative 1 are products of a perfect square and the variable. For example, n to the fifth is the same thing as saying n to the fourth times n. So the square root of n to the fifth would be the square root of n to the fourth times n. The square root of n to the fourth is n squared, and the square root of n can't be broken down, so it ends up to be n squared times n. Let's look at some examples so we can practice this. We're going to simplify 243. Okay. I know that it's divisible by 3 because 4 plus 3 is 7, 7 plus 2 is 9, and 9 is divisible by 3. So I'm going to take this number. I'm going to divide it by 3. So this is 3 times 81. And 81, I already know, is 9 times 9. I know 9 times 9 is not prime, but it's a perfect square. Therefore, here's my pair of numbers. Okay, my pair is 9. That goes on the outside. What doesn't get paired up goes to the inside. Kind of think of it as this. 2 people go on one date. Okay? 2 people go on a single date. What's ever left underneath the radical stays underneath the radical. Whatever does not get to go on the date has to stay underneath. Look at 250. That's 25 times 10. 25 is 5 times 5. 10 is 2 times 5. I'm going to pair up my numbers. I can pair up the 5s, but the 2 and the 5 don't get paired up. So the 5 comes out, and the 2 and the 5 stay back underneath. Multiplied together, they become 10. So this became 5 square roots of 2 times 5, which equals 5 square roots of 10. Number 3, we already have a number outside of the square root. What that simply means is it means negative 5 times the square root of 300. Which means once I break down the square root of 300, I have to multiply that by the negative 5. Okay, I happen to know that 300 is 3 times 100. And 100 is 10 times 10. These are perfect squares because they can pair up, can't they? So they can go out. This gets multiplied by the negative 5. So I have the negative 5 gets multiplied by the 10. And what's left over? The square root of 3. So this becomes negative 50 square roots of 3. I am done with that problem. Now let's start looking at some problems that have variables. I'm going to do square root of 720, a to the third, b to the sixth. Okay, 720, that's 72 times 10. Right? 72, 8 times 9, right? 10, 2 times 5. Those are finding prime. 8 is 2 times 4. 4 is 2 times 2. 9 is 3 times 3. Let's see what I can pair up. Pair up my 3's here. I can pair up this pair of 2's here. I can pair up this pair of 2's right here. So number-wise, what comes on the outside? 2 times 2 times 3. The 5 stays underneath. Variable-wise, I basically have here variable-wise, let's look at this for variables. A times A times A times B times B times B times B times B times B. I have 3 A's and 6 B's. So if I'm going to pair them up, these A's get paired up. Okay, these B's, these B's, these B's get paired up. So I can take out 1 A and 3 B's. So I get 2 times 2 is 4, times 3 is 12, so this becomes 12. A, B to the third, square roots, make sure you don't get that 3 too close to your square root symbol. Square roots of 5, and how many A's do I have left? A. So my final answer then is this right here, 12ab to the third, square roots of 5a. Let's look at number 5. Now I have a 2x on the outside, so I'm going to have to remember to take that into consideration after I've simplified. 2,952. Well, I know it's divisible by 2, so I think I'll start there, because at least I know I can do that. That's 2 times, let's see, 2,952 divided by 2 is 1,476. I'm going to divide that by 2. 2 times 738, which is 2 times, remember if something is even, it's always divided by 2. 369. I happen to know that 369 is divisible by 13. No, it's not. 369 is not divisible by 13, is it? Nope. I'm thinking 169. Okay. So 369 is divisible by 3, though. If I take 369 divided by 3, I get 3 times 123, which happens to be divisible by 3 again, which is 3 times 41. And I can already tell you this, 41 is prime. If you don't know if something is prime, and you're in the classroom, I have a primes to 10,000s chart in the back. Feel free to use it whenever you want. All right, so number-wise, let's pair my numbers up. I can pair up this pair of 2s right here. I can pair up this pair of 3s right here. The 2 and the 41 stay underneath. So far I have 2x that was already on the outside, times 2 times 3. Okay. How many x's can I take out? Well, take 7 and divide it by 2. It goes in how many times? 3 with a remainder of 1, correct? It's 3 remainder 1. So 3 x's can come out, 1 x has to stay in. So this would be x to the third. So, and then we have underneath, we're going to have 2 times 41 times x. So my answer is going to be 2 times 2 is 4, times 3 is 12, 12, x to the fourth power, because x to the third times x is x to the fourth, square roots of 41 times 2 is 82, x. So 12, x to the fourth, square roots of 82x. Let's look at number 6. No numbers on the outside. Yay! 132. That's divisible by 2. That's 2 times 66, which is 2 times 33, which is 3 times 11. Okay, so number-wise, I can take out a 2. The 3 and the 11 stays underneath. For my x's, I will have 2 divided by 2, which means I can take out 1. For my y's, I have 5 divided by 2, which is 2 remainder 1. So I can take out 1x and 2 y's, and I have a y remaining. So on the outside, I'm going to have 2. I'm going to have my x. I'm going to have 2 y's, so y squared. On the inside, I will have my 3 times 11. 3 times 11 times my remaining y. So I have 2x y squared, square roots of 33y. I think that's all 12 on that page here. Let's go to the next page for a second. Now, that was simplifying radicals. Now we have to learn how to multiply radicals. When you multiply radicals, remember to multiply radical by radical and constant by constant. In other words, inside times inside and outside times outside. Okay, it's the easiest way to remember it. So the square root of 8 times the square root of 12 is the same thing as saying the square root of 8 times 12. Okay, 12 times 8 happens to be 96. So this is the square root of 96, but the square root of 96 will break down. Okay? Since I know the square root of 96 breaks down, I have to break it down. Because once you multiply something, you have to put it in the simplest form when you're done. It's kind of like fractions. When you add your fractions, you have to simplify them when you're finally done. Same thing here with radicals. So this is 2 times 48, which is 2 times 24, which is I'm running out of space, so I'm just going to move this a little bit. I'm just going to erase this so I can do this better. This is the square root of 96, which is 2 times 48, which is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So, I can pair up this pair of 2's, this pair of 2's, this 2 and this 3 stay. So I end up with 4 square roots of 6. And I am done. Okay, 5 square roots of 3 times 6 square roots of 6. Remember what I said. Constant times constant, radical times radical, or easier to remember, outside times outside, inside times inside. Outside the radical times outside the radical, inside the radical times inside the radical. So this, 5 times 6 would be 30. Square roots of 6 times 3 is 18. Does 18 break down? Yeah, it's 2 times 9. And 9 is 3 times 3. So this 3 goes outside, gets multiplied by that 30. So this becomes 30 times 3 is 90. Square roots of 2, because my 2 is right there. 90 square roots of 2 when I multiply those two things together. The square root of 13 squared means the square root of 13 times the square root of 13, which is the square root of 169, which is 13 times 13, which is just 13. Interesting thing about squaring a square root. You should remember this, squaring a square root. Square root is the opposite of squaring something, and squaring is the opposite of square rooting something. So this square negates this square root. So this square cancels out that square root, and all you're left with is the number. Let's do a couple more. 2 square roots of 5a squared times 6 square roots of 10a to the third. Outside times outside, that's 12. Inside times inside would be 50. A to the fifth. Remember, you add exponents in chapter 8. 50 is 5 times 10. 10 is 5 times 2. So this 5 is multiplied by that 12, so that makes it 60. I have a to the fifth, so my a's is going to be 5 divided by 2, which is 2 remainder 1. So 2 a's come out, and an a stays underneath along with this 2, so this will be 2a. So we have 60a squared square roots up to a. The more you do these, the better you get at them. And I'm giving you lots and lots of examples because I don't want you to get confused. I want you to see all the different possibilities here. Let's look at this one. Outside times outside, that's going to be 21. Inside times inside, 8 times 5 is 40. 40x squared. 40 is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. Pair up my numbers. Pair up 2. That goes outside and gets multiplied by the 21. 21 times 2 is 42. What's left? 2 times 5, which is 10. How many x's can come out? 1, because 2 divided by 2 is 1. So 42x square roots of 10. Now, when we have 2 square roots of 6a squared quantity squared, this literally means 2 square roots of 6a squared times 2 square roots of 6a squared. Okay. Remember back in chapter 8, we learned that you have to distribute this square root. Okay, if you're going to do it that way. You can do it this way, which is writing them out, or you can distribute your square root. You should come up with the same answer either way you do it, provided you do it right. So if I do it with writing them out, outside times outside, that's 4. Inside times inside, 6a squared times 6a squared is 36a to the 4th. But 36 is 6 times 6, so that can come out. That gets multiplied by 4. That becomes 24. A to the 4th, 4 divided by 2 is 2, so I can take out 2 a's. So it comes out to 24a squared. Everything comes out of the square root of this particular problem. If I was going to distribute my exponent, like I did in the little green arrows up there, if I have 2 square roots of 6a squared, and I'm going to take that, square it, and I distribute this 2, I would have 2 squared times, this 2 cancels out this square root, so it would be times 6a squared. 2 squared is 4, so I would have 4 times 6a squared, which is 24a squared, which is exactly what I've done right there. It doesn't matter which way you do it, as long as you do it correctly, you should arrive at the correct answer. So this is simplifying and multiplying radicals. We'll get into dividing radicals in the second half of this lesson.